Okay, notes 8.3, we're going to be looking at linear and absolute value functions. So linear, remember, is just like a straight line when you're graphing it, and it just has an x. Absolute value is a v when you graph it. It has absolute value of x. Okay. Now this first one, notice number 1, we're missing a variable here. This is a constant graph. The parent function is actually at 0, so it's the x-axis, okay? So if we plug in a -2 for x, notice there's not an x, okay? So if I plug in a -2, there's no x, so I'm still going to get 3. If I plug in a -1, again, there's not an x value, so you're still going to get 3. 0, 3, 1, 3, 2, 3. Okay, so it's going to be a horizontal line. So -2, 3, -1, 3, 0, 3, 1, 3, and 2, 3. So it's just a straight, should be straight, horizontal line. Okay? Alright, so the domain, the x values. If you look at the x-axis here, notice it's continuous both ways, so it would be all real on the domain. And then your range, if you look, every single y value is 3. So y equals 3 would be your range, because every single y value is 3, no matter what you plug in, because there's not a variable to plug into. Alright, so looking at 2, f of x equals x. This is the linear parent function. Alright, so let's start with, we'll just say -2. If we plug in a -2, we're going to get -2. If we plug in a -1, we're going to get -1. If we plug in a 0, we're going to get 0, 1, 1, and 2, 2. Okay, so and it's continuous, so just draw your straight line. So that is the linear parent function. It crosses at the origin. Remember, we've talked about before, a linear function, your domain and range will always be all real numbers because it's continuous both directions. So domain is all real, the range is all real. So that's the linear parent function, f of x equals x. Notice on 3 we have f of x equals the absolute value of x, because those vertical bars, that symbol means absolute value. So this is the absolute value parent function. Okay, so let's plug in a -2. If we plug in a -2 in for x on this function, we're taking the absolute value of -2. Remember, absolute value means the distance the number is from 0. So if you plug in a -2, that answer would be 2. If you plug in a -1, absolute value of -1 is +1. If you plug in a 0, you get 0. If you plug in a 1, you still get 1, and then 2, 2. So if you plot those points, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. So it's a V. So anytime you have a V on your graph, you know that it's absolute value. You have to know what type of function is just by looking at the graph. Okay, so domain, look at your x-axis. Notice it's continuous to the right and to the left. So domain would be all real numbers. You can plug in any real number in for x. The range, notice it's everything greater than or equal to 0, because when you're plugging in for x, you're always going to get a positive because it's the distance the number is from 0. So your range will be y is greater than or equal to 0. Okay, so we need to figure out what type of function we have before we know what we need to do. Okay, so on example 4, notice this is a linear function. Okay, we're going to write the transformations down. The negative in front reflects it. The 2 stretches it by 2. And then plus 3 on the outside. We do not have parentheses, so remember when you don't have parentheses or it's not under your square root, that is a vertical shift. So if it's plus 3, we're going to be going up 3. Okay, so you can use the transformations here, so let's do that. So we're shifting our 0, 0 point up 3. So there's that new point. From there, we're acting like that's the new origin, but we're having to stretch by 2 and reflect. So if you remember back from your linear parent function on the front, our points were -2, -2. -1, 0, 0, 1, 1, and 2, 2. So we're having to reflect, which changes the sign, and we're having to stretch by 2. So basically you're multiplying by that -2 in front. The 0, 0 doesn't change. So instead of going left 2, down 2, we're doing left 2, up 4. And then left 1, up 2. Right 1, down 2. From that 0, 0 point, right 2, down 4. Now, since this one is linear, we already know how to graph that. So you could also use the slope and the y-intercept. So if you wanted to do that, slope would be -2 over 1. Y-intercept would be 3. So it crosses the y at 3, and you're going down to right 1. It should give you the same graph. So on the linear one, since we already know how to graph those, you can, instead of using your transformations, you can also just use slope and y-intercept if you want to do it that way. Alright, so domain, remember we talked about on the front. On a linear function, domain and range will always be all real numbers because it's continuous both directions. Okay? Alright, let's look at 5. Notice this is absolute value. We have to know what type of function, so it's going to be a V. If you remember back on your parent function, absolute value of x, we plugged in a -2 and got 2, -1, 1, 0, 0, 1, 1, and 2, 2. Okay, so those were our parent function values. Alright, so let's write our transformation down. Inside the absolute value, just like inside parentheses or under your square root, that's going to be a horizontal shift. If it's x minus 5, remember that's going to be a right. So we're going to the right 5. And then the plus 2 on the outside will be shifting up 2. Okay, so on your absolute value graph, you do have a 0, 0 point. That's the point of your V. Okay, so that's what we're going to be shifting. We're going right 5, 1, 2, 3, 4, 5, up 2. There's my new endpoint of my V. I'm acting like that's the new origin, and then I'm plotting my parent function chart, or parent function table. So -2, 2. So left 2, up 2, left 1, up 1, right 1, up 1, and right 2, up 2. So there's my new V. So you're always referring back to your parent function of that type of function. So you have to know, is it linear? Is it absolute value? Is it square root? Is it quadratic? Okay, you have to determine that. If you look at the x-axis, your domain would be all real numbers. So you can plug in any real number in for x. And then your range, if you look at the y-axis, This value is 2 here, and we're using everything above it. So that would mean y is greater than or equal to 2. Okay, so number 6. Notice that we just have an x. This is linear. So we should have a straight line when we graph it. The transformations, inside parentheses, it says x minus 2, which means you're going to be going to the right 2, and then the plus 4, you're going to be shifting up 4. So remember, you do have a 0, 0 point. So let's go ahead and write down our points from our f of x equals x. That was -2, -2, -1, -1, 0, 0, 1, 1, and 2, 2. So that's our parent function. All right, so I'm going to shift right 2, up 4. From there, that's my new origin, so I'm using the parent function values. So -2, which means left 2, and then down 2. And then left 1, down 1, right 1, up 1, right 2, up 2. Again, since this is linear, you could just combine these two. So that would be x plus 2, and you could use slope and y-intercept. So on the linear ones, if you want, you can either use the transformations or you can use your slope and y-intercept. Okay? Remember, linear function, all real numbers for domain and for your range. Alright, so looking at 7, this is absolute value, so we should have a V on our graph. Let's write down our transformations. The negative in front reflects it. Remember, that just changes the y value sign. Then the 2 is a stretch. Notice inside the absolute value bars, there's not a plus or a minus. We're not adding any or subtracting anything, so there's not going to be a horizontal shift. On the outside, we're adding 1, which is a vertical shift. We'll be going up 1. So on your V, we do have a 0, 0 point. That's the point of your V. So we're going to shift it up 1. We're not shifting left or right, just up 1. Okay, I'm going to go ahead and write down my parent function values. Absolute value of x was -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. Okay, so we're having to reflect, which changes the sign, and stretch by 2. So I need to multiply my original y by a -2, because the reflection changes the sign, and then you're stretching by 2. So I'm going to multiply that by -2. So that's -4. The 0, 0 doesn't change. Okay, so I'm acting like my 0, 0 point that I shifted is now my new origin. So I'm going left 2, down 4. Left 1, down 2. And then right 1, down 2. Right 2, down 4. So there's my V. Notice it's opening down just like a parabola. Anytime there's a negative in front, it will open down because you're reflecting it across the x-axis. Okay, so if you look at your x-axis, it's continuous both directions. So all real, we can plug in any real number in for x. Your range, if you look at the y-axis, that value is 1 and it's everything below it. So your y values would need to be less than or equal to 1. Okay, next part. We're going to be writing the equation for each of the following. So always pay close attention to what function you're starting with. So notice that we're starting with f of x equals the absolute value of x. If you're starting with that, that means your answer should have an absolute value symbol in it. Okay? So we're reflecting across the x-axis. That just puts a negative on it. You're stretching by 3. That's just your coefficient in front. You're going to the left 4. So that would be plus 4. And then you're going down 1, so minus 1. So write your function, we'll just call it g of x equals, it's an equation, you have to put that. Okay, so we're reflecting, stretching by 3, we're shifting to the left. So inside the absolute value bars, you should have x plus 4, and then you're going down 1, so minus 1. So again, pay close attention to whatever function you're starting with at the beginning. Okay, so 9, you're starting with f of x equals x, that's linear. You're stretching by a factor of 2, so that's just your coefficient. You're shifting to the right 3, which would be minus 3 in parentheses. And then you're going down 6, which would be minus 6. So we have stretch by 2. In parentheses, we have x minus 3, and then minus 6. So we don't have a squared, we don't have absolute value bars, we don't have a square root, because we're starting with linear. F of x equals x. Okay, so on your number 10, we have a graph. Okay, the easiest way on the linear ones is just to find your slope and your y-intercept. Okay, you could also find your transformations. Okay, all right. So I'm just going to find m and b. Your slope, pick a point, go to the next one. We're going up 2, right 1, and then your y-intercept is negative 2. So that would be 2x minus 2. Okay, so on the linear graphs, it's easier if you just find slope and y-intercept, and that will help you with determining what your graph is. Okay, 11, we have a v. If we have a v, we know its absolute value. Okay, so my endpoint of my v was my original origin. So I need to look and see where it's shifting. It's going left, 1, 2, 3. It's going up 2. Notice it's opening down, so that's a reflection. You also need to check your points. Normally it's 1, 1. So that would be 1, negative 1 if it's a reflection. Then 2, 2. Notice that it does give you those points. Okay, so there's not a stretch or a shrink there. All right, so writing your function. You're going to have vertical bars because that's absolute value. So you're going to the left 3, which means x plus 3 inside the absolute value bars. And then up 2 would be a plus 2 on the outside. Now, remember we had that reflection, excuse me, reflection. We're going to put a negative in front of that absolute value bars. Okay, let's look at 12. So let's check our 0, 0 point. It went to the right, 1, 2, 3, 4, and down 1, 2, 3. Notice it's opening up, so we shouldn't have a reflection, no negative. Let's check our points. The points are usually 1, 1, 2, 2, negative 1, 1, negative 2, 2. So let's check it. If we start here, go right 1 and then up 2, but it's normally right 1, up 1. So you're having a stretch by 2 because you're going right 2, also up 4. So you're having to multiply that original y value by 2. That's why it's very important that you know your parent function of that type of function and those values in the table. So it's absolute value, so we're going to go right 4 So that's x minus 4 inside your absolute value bars. Down 3, so that's minus 3 on the outside, and you're stretching by 2. So you need to put that 2 in front. Okay, so this is going over absolute value graphs and also linear.